3, 2, 1. We have ignition and liftoff of the United Launch Alliance Atlas V rocket.
Go out. Move Centaur.
Good morning and welcome to Space Launch Complex 41 and ULA's live coverage of the Atlas V launch of Amazon's Leo 4 to low Earth orbit. I'm Pam Ziert and I'm a mechanical engineer at United Launch Alliance. I'm joining you from ULA's Advanced Spaceflight Operations Center here at Cape Canaveral Space Force Station in Florida. We also have team members on console at ULA headquarters in Denver, Colorado. Liftoff is scheduled for 3:28 a.m. Eastern at the opening of today's 29-minute launch window. Launch windows vary by mission and are determined by the payload's destination. Today's mission is going to low Earth orbit, also known as LEO, and has multiple orbit insertion opportunities. Today's coverage will continue through the start of the first second stage engine burn. For additional real-time mission coverage, follow along with our live blog at ulalaunch.com. And if you enjoy watching our live broadcasts, don't forget to subscribe to our YouTube channel for access to future missions, launch highlights, and behind-the-scenes rocket content. At this time, the team is not working any issues, and we're proceeding towards a 3:28 a.m. liftoff. Right now, we're taking a live look at the Atlas V rocket on the launch pad. As the countdown continues, our team is taking the final steps in preparation for liftoff. The first stage, also known as the rocket's booster stage, is a large tank on the bottom that is actually two tanks, one filled with RP-1 fuel and the other with liquid oxygen. The liquid oxygen is a super cold cryogenic propellant that turns the tank exterior from bronze to a frosty white. Atlas is also equipped with the Centaur upper stage, which drives the payload during the second phase of flight to its final orbital destination in space. The payload fairing, or PLF, completes the rocket and provides the aerodynamic shape necessary for the climb to space. On the payload fairing, we're proud to display new artwork representing Amazon's Leo program, shown here in its signature Krypton color, along with the American flag and logos for Atlas and ULA. Rebranded recently from Project Kuiper, the Amazon Leo name is a simple nod to the low Earth orbit satellite constellation that powers this new network. And if you look closely, you'll see the logo includes an aurora made up of the letters LEO. Let's learn more about how ULA builds the Atlas V rocket.
Engineered in Centennial, Colorado, ULA's Atlas V rocket is built in Decatur, Alabama, and launched from Cape Canaveral, Florida. Once the rocket is manufactured, it travels to Cape Canaveral on ULA's cargo ship, known as Rocket Ship. After arriving in Florida, ULA's launch operations team begins assembling the rocket. Stacking begins with lifting the 107-foot Atlas booster, powered by an RD-180 engine, onto the mobile launch platform. 5 solid rocket boosters are attached to the sides of the first stage for additional thrust at liftoff. ULA's ultra-thin stainless steel Centaur upper stage, powered by an RL-10 engine, is then lifted into position. Lastly, the payload fairing, containing the spacecraft, is lifted and mated to the Atlas V rocket. Once assembled, the countdown begins with moving the rocket from the vertical integration facility to the launch pad. The trip to the pad is about 1/3 of a mile. Throughout the 20-minute trip, a payload van leads the move, providing communication with the spacecraft, followed by the ground van providing support to the rocket. The mobile launch platform supplies air conditioning, electrical, and propellant lines to the rocket. Track mobiles at the rear power the convoy, which includes an environmental control system providing air conditioning to the payload and rocket, as well as a backup generator. Atlas arrives at the pad for fueling and other final preparations, and once fueled, weighs nearly 1.3 million pounds.
As previously mentioned, the Atlas booster is comprised of 2 tanks, and you may be wondering why one tank isn't quite as frosty as the other. The upper booster tank is filled with super cold liquid oxygen. The fuel tank, however, is filled with a rocket propellant known as RP-1, and unlike liquid oxygen, it can exist as a liquid at room temperature. This chemical property saves us time on day of launch because we can start tanking on the same day we rolled a pad and not have to worry about propellant boil-off. This phenomenon only occurs with cryogenic propellants and is even happening right now, as seen by the white plumes coming off both stages. For today's launch, the Atlas first stage fuel tank was filled this past Saturday immediately following roll to pad. And because it doesn't boil off, it was already tanked to its flight level before we even started our countdown operations today. Today's mission will deliver another 27 Amazon LEO satellites to orbit. There are billions of people on the planet who lack access to high-speed internet, and millions of businesses, governments, and other organizations operating in places without reliable connectivity. The Amazon LEO constellation will help bridge that gap by delivering fast, reliable internet to customers around the world. Let's learn more.
And the next equation is 18 minus 8 equals 10.
Ready for liftoff. All
Stage 1 at 10.
At ULA, we're completing major infrastructure upgrades at our launch facilities here in Cape Canaveral, Florida, which are dedicated to future Amazon LEO missions atop Vulcan rockets. We've built a second vertical integration facility, also known as VIF-A for Amazon, where we will soon process Amazon LEO missions flying on ULA's new Vulcan rocket. This facility includes new integration capabilities for processing and fueling the Centaur 5 upper stage, as well as a second launch platform dedicated to Amazon missions. This second processing facility is a critical element in adding to our future launch cadence. These upgrades provide the capability to process 2 rockets at a time, one in the Amazon facility and one in our government-dedicated integration facility. Both facilities will be used to stack and process rockets before they roll out to the launch pad, enabling dual launch capabilities. Once complete, processing will begin on the first of many Vulcan Amazon LEO missions in this new facility. As it stands on the pad today, the Atlas V rocket comes in at over 200 feet tall. But did you know it contains hundreds of thousands of feet within it? It may sound like a brain teaser, but the answer is pretty simple. Down the side of the Atlas booster, you may notice an area sticking out a little bit more. This area is called the pod and raceway, and it contains all of the critical avionics and instrumentation for the booster stage. The components within this system, like the flight computers and batteries, are connected with wire harnesses, and hundreds of them. You can almost think of the pod and raceway like the human nervous system. Our nerves connect our brain to the rest of our body by running down our spine. If lined up end to end, the pod and raceway wire harnesses would span over 100 miles long, which is the equivalent of stacking Mount Everest on top of itself nearly 25 times. What's even more unbelievable is this doesn't even include the hundreds of harnesses installed on the Centaur upper stage or payload fairing.
All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
Terminal count briefing. If a condition exceeds a launch constraint any time after the terminal count status check, the observer shall announce hold. Channel 1, identify their station, and briefly state the reason for the hold. Flight control, perform launch on time verification.
Roger.
OSM, place SRB ignition SNA switch in the enable position.
SRB ignition enabled.
LOX 2, verify CISA purge flowing GN2 to the CISA.
Verified.
OSM, verify the FCO, ROC, and OSM fire switches are in the proceed position.
Ready to proceed.
RLM, verify red line monitor and vent table are in the correct configuration for terminal count. Verified. RC, verify solar radiation.
As we get closer to the opening of our launch window, let's have a look at the weather forecast our launch team just received from Space Launch Delta 45 Weather Officer Jimmy Tager. Today's forecast for launch is looking good. The probability of violating constraints is 10%. Ground winds are 8 to 15 knots out of the north, and the temperature is 58 degrees Fahrenheit. The primary concerns for launch are the liftoff winds and cumulus cloud rule.
Roger. LC switch is ready.
The Atlas rocket comes in many different configurations to support our mission needs, and this key is a really easy way to decipher what configuration we're launching today. The first number, either a 5 or a 4, represents the diameter of the payload fairing. The second number represents the number of solid rocket boosters attached to the main booster to augment the thrust at liftoff and can accommodate anywhere from 0 to 5. The last number is the number of upper stage engines. In today's case, it's a single engine Centaur mission. However, we do also offer a dual engine Centaur configuration. Once we lift off, viewers watching launch from Florida and points northeast may be able to see the Atlas V rocket in flight. To get a closer look at this visibility map, check out @ULA Launch on social media. We remain in the planned 60-minute hold as we continue towards liftoff. In a few moments, ULA launch conductor Scott Barney will poll the team for the final go to pick up the countdown. The launch conductor manages the launch team during the countdown, ensuring that all systems are performing nominally and that every member of the team is following their procedure and executing per the planned timeline. 28 engineers are polled to confirm the rocket is ready to proceed. This is the final status check for all Atlas vehicle systems, ground systems, the payload, and the U.S. Space Force Eastern Range. Let's listen in as he performs the poll.
Terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur system, propulsion. Go. Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Op support.
Go.
COM. Go. Umbilicals.
Go.
Environmental control system.
Go.
Red line monitor. Go. Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range and weather.
Go.
Launch director.
LC, this is LD. You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 0828000.
Polling is complete and the team is go for launch. From now until liftoff, launch conductor Scott Barney and the launch team will continue reporting the final steps in today's countdown. This includes verifying propellant levels and pressures in the booster and Centaur fuel tanks, as well as arming the ordnance for ignition, separation, and flight termination. At T-1 minute, the range confirms it is in a green condition for launch, assuring there are no nearby constraints like boats, planes, or weather, and that all tracking systems are operational. At T-25 seconds, you'll hear, "Go Atlas, go Centaur, go Amazon Leo." This is the final status check for the rocket and payload. To dampen the acoustic shock at liftoff, at T-6 seconds, the launch pad's water deluge system activates, followed a few seconds later by booster engine ignition. Then, after seeing Atlas lift off, you'll hear flight commentator Sarah Bailey Glasgow providing updates as the rocket ascends into space. It may be the season of holly and jolly, but our engineers are paying close attention to something we call LOLLY. LOLLY stands for Limited Operational Life, and it is a methodology used to track what each piece of hardware has been through during processing. You can think of it a bit like an expiration date, but rather than looking at time, many of our components look at cycles. For example, how many times did we open and close a valve, or how often did we pressurize a tank over a certain value? The majority of our hardware is tested numerous times before it ever leaves the ground, and LOLLY provides our team with a way to ensure it remains within its qualified limits before launch, with plenty of margin to spare. This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
Minutes and counting. 3, 2, 1, mark. 3:55.
The countdown clock has resumed, and we are go for launch at 3:28 a.m. Eastern. After liftoff, ULA's Atlas V rocket will fly northeast from Space Launch Complex 41. Here's a look at today's flight.
Following final confirmation of rocket readiness, the RD-180 engine and 5 GEM 63 solid rocket boosters ignite to produce more than 2 million pounds of thrust, lifting ULA's Atlas V rocket away from the pad. Shortly after liftoff, the rocket begins a pitchover to attain the proper flight path while minimizing the dynamic pressure it experiences during flight. Atlas then reaches Mach 1, the speed of sound. The addition of 5 solid rocket boosters, or SRBs, precisely augment the liftoff thrust of the Atlas V, giving it the power to deliver the payload to orbit. With their propellant expired approximately 96 seconds into ascent, the SRBs burn out, followed by jettison. Atlas's guidance system then begins steering towards the precise target in space. Amazon's LEO satellites are encapsulated inside a 5-meter diameter payload fairing, which provides protection to the spacecraft during ascent. After crossing the Kármán line, entering space, the payload fairing is jettisoned. With the majority of propellant expended fighting against the force of gravity, the RD-180 engine shuts down and the booster stage separates. The rocket then begins second stage flight, weighing less than 7% of what it did at liftoff. ULA's high-performance Centaur, with its RL-10 engine, ignites, powering the upper stage and spacecraft into a circular low Earth orbit. The first burn comes to an end with engine shutdown. Centaur then rotates into the precise position to release Amazon's LEO satellites, spacecraft that will deliver fast, reliable internet to customers around the world.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137.
T-minus 90 seconds. The launch vehicle, ground systems, payload, and Eastern Range are go for launch. For those of you just tuning in, I'm Pam Ziert, joining you for today's live coverage of ULA's Atlas V launch of Amazon Leo 4. At this time, the team is not working any issues, and we're proceeding towards liftoff at 3:28 a.m. Eastern.
110.
And valves locked.
T-minus 1 minute.
Rock, report range status.
Range green.
Stable at step 3.
Verify ECS reduced for launch.
Verified.
Status check.
Go Atlas.
Go Centaur.
Go Amazon Leo.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1, and Liftoff of the United Launch Alliance Atlas V rocket, carrying 27 satellites for Amazon LEO, spacecraft delivering fast, reliable internet to customers around the world.
Strong closed-loop control, engaging first throttle segment as expected. And we've completed our pitch program. Hydraulics continue to look good. Successfully completed roll program. Booster engine continues to operate as expected. Mach 1, Atlas V is now supersonic. Engine continues to operate as
We're hearing
expected.
Sarah Bailey Glasgow providing launch vehicle ascent data.
Vehicle is now 6 miles in altitude, 2 miles downrange. Atlas continues to move down the center of the range track. Now passing 1 minute into flight. Body rates continue to look good. Engine operating as expected. Throttling down, engine continues to burn normally. Atlas is now moving at 2,800 miles an hour and is 12 miles downrange. Vehicle is now 1/2 of its liftoff weight, max Q, passing through maximum dynamic pressure. And we have good indication of SRB burnout. Throttling up as expected. And we have good indication of separation of all 5 SRBs. Engine continues to burn normally.
We just heard confirmation of solid rocket booster jettison. These additional motors augmented the thrust at liftoff to give the Atlas rocket an extra boost to reach its circular low Earth orbit destination. We're coming up on our next mission event, jettison of the payload fairing. Let's listen in.
Body rates are smooth. Two minutes to a nominal BECO. Vehicle continues to move down the center of the range track. Holding acceleration at 2.5 Gs in preparation for payload fairing jettison. Centaur reaction control system pressurizing to flight levels as expected. Vehicle has passed the Kármán line. We've exited Earth's atmosphere. Atlas is now 1/4 of its liftoff weight. Engine continues to burn as expected. And we have good indication of payload fairing jettison and CFLR deck jettison, throttling back up as expected.
Flight commentator Sarah Bailey Glasgow just called out confirmation of payload fairing jettison. The composite fairing protects the spacecraft as it pushes through the harshest parts of Earth's atmosphere. Next, we'll hear callouts for cutoff of the Atlas first stage engine and separation of the booster stage, followed by ignition of ULA's Centaur second stage engine. These events occur when the first stage has escaped Earth's atmosphere, getting above the Kármán line and into space. The Centaur upper stage, with the Amazon LEO satellites attached, then takes over on a trajectory to a precise location in space. Let's listen in as we approach these milestones.
Boost phase chill down in progress. Temperatures are operating as expected. Engine continues to burn nominally. PU has gone to open loop control. Boost phase chill down complete. Temperatures operated as expected. And we have successful cutoff. And good indication of Centaur separation. Pre-start on fuel and LOX, good staging. Ignition and full thrust. Railton is running nominally. Engine continues to burn as expected. Steering has been enabled.
This is Atlas Mission Control at T+5 minutes. We just heard flight commentator Sarah Bailey Glasgow confirm the successful completion of the early milestones in today's flight, and all systems continue to operate nominally. Today we learned about the Amazon LEO mission and its ability to provide reliable internet to underserved communities. ULA's launch site also is undergoing upgrades to support dual launch capability. As we wrap up our live coverage, we want to say thank you for staying up late or waking up early to tune into today's flight, and remind you to visit ulalaunch.com. Follow us on social at ULA Launch, and subscribe to our YouTube channel for launch updates, video, and other content. Before we sign off, let's take another look at today's liftoff.
10,
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition, 2, 1, and liftoff of the United Launch Alliance Atlas V rocket, carrying 27 satellites for Amazon LEO, spacecraft delivering fast, reliable internet to customers around the world.
Strong closed-loop control, engaging first throttle segment as expected. And we've completed our pitch program.